All right, we're still in PACE 1111. We're going to look at pages 49 to 54, which is about, let me find my marker, the ideal gas law. And that basically states that just about every gas at fairly normal temperature and pressure responds in a very similar way, no matter what the gas composition is, no matter what element makes it up. So anyways, a very important term that we need to learn about is called the mole. Now, they're going to talk more about this in a future PACE, but they're just going to introduce this here and have you answer one question in your homework and on your checkup, self-test, PACE test. But let's talk about this briefly because this is kind of a weird term. If I were to tell you that you're going to make scrambled eggs for camp or for a school activity or youth group activity, how would I tell you how many eggs to buy? Am I going to tell you the individual eggs? Probably not. I'll probably say buy 5 dozen eggs, right? Or we need 2 dozen eggs. So what is a dozen? A dozen is a number that we use that tells us that we need 12 of something. My wife likes to bake chocolate chip cookies, as you can tell. And they are very delicious. And she makes them by the dozen. So she might make 4 dozen or 6 dozen. Or if we have a big activity at church, she might make 10 dozen cookies. So a dozen is just 12 of something. So the word mole is a word that a guy named Avogadro came up with. Does it tell us here? Oh yeah, 6.022 times 10 to the 23rd power. So that's not 12. That's a pretty big number. 6.022 times 10 to the 23rd power. That is a lot of something, okay? So 1 mole would be like trying to count out all of those particles of a gas, okay? Or of something else with mass, all the atoms. When you have that many atoms in a little pile, it's called 1 mole of that substance. That's going to become very important as we keep going through chemistry, but I just wanted to introduce that to you now. We'll dig into it deeper in the future. Now, let's take this formula. PV over NT equals R. P, by now you know, is pressure. V is volume. T is temperature. You know that. N is the number of moles of that gas. Okay, number of moles. So like I said, it's just a way that we measure things. It's usually a number with a decimal, or sometimes it's just a decimal number. Okay, but that tells us how much substance we have. And then R is a constant. And in these problems, thankfully, they're going to keep the units pretty consistent. So the key is just to know this number, 8.314. Okay? Now, let's talk about how to use this formula, because usually they're going to have us solve for one of these 4 things over here. I think the easiest way to start is to multiply both sides times NT. Okay? And so then this cancels and this cancels, so I have PV equals N, R, and T. So all 3 of these are on the same side. In fact, this is usually the form that I have seen this formula in. I don't usually see it in this one. This is the way they have it in the PACE and kind of have you memorize it. This is a little more familiar, and you might see it in college, but it's the same thing. See, all I did was just rearrange it by multiplying times the denominator. So looking at this problem that we have here, it says we want to solve for the volume. So I have the pressure given, the number of moles, 9.4 MOL doesn't mean molecules, it means moles. Of course, I know the R value, and then the temperature is in Kelvin, 273. But if I'm going to solve for V, then that means I need to divide by P. And I'm going to do the same thing on both sides of the equation. So now this is my new formula to solve for volume. Okay, does that make sense? So we take this formula, divide by P. Now I've got my formula. I'm going to plug in N, which is 9.4, R, 8.314, T is 273, and we're going to divide by the pressure, which is 101.3. All right, so I want you to do this with me. Get your calculator out. Let's see if you get this. 9.4 times 8.314. Are you doing it with me? I don't want to be the only one doing this. Come on. I did 223. I don't want 223. I want 273. See, being sloppy, Mr. Anger. Equals, so I get 21,335 point blah, blah, blah. And I'm going to divide by 101.3. All right, I'm getting 210.616, etc. All right. How many significant digits can we have for this one? We have 3, 4, 2, 4, so I can only have 2 significant digits in my answer. So I need to round it off to just 210. Notice it's not 211 because that would be 3 significant figures. So really this 0 is not significant. I stopped here and I looked at this 0 and rounded this up, or rounded this to stay the same at 210. Okay? Now one other thing I just want to point out to you in your PACE, if you go back to what page am I on? 52. In this example that they're doing here on the bottom of page 51, it wants you to identify what is the gas? What kind of gas do we have? Is it neon? Is it argon? Is it chlorine? What is it? And so they give all the information up here, and they even give you something else called M for mass, but they don't give you the N. So you solve this. Okay, we're going to solve for N, so we're going to divide by RT on both sides. So that's what they have here. And then you plug in everything and you get the N value, and that's the number of moles, okay? Then they have a formula here called the molar mass, and we take the mass that they gave us and divide by how many moles we have, and now we have the number of grams per mole. And then they explain in this step 7 how to identify that that is chlorine. Okay? Now the example they give, it's a little bit tricky because you have to realize, oh yeah, chlorine is a diatomic molecule, so it's 2 chlorines, you have to actually divide by 2. I don't think we covered that yet. Maybe we did. But I think the 2 in their homework, you can just look right at the periodic table and find the mass that's the closest to that, and it should work. Okay, that takes you right up to the last checkup, and then you have a self-test and the PACE test. I hope you do well on both.